So the first word problem says a grid has been superimposed on the gateway arc in St. Louis. Find the equation that models the arc. So what's the question asking me? Find an equation. Okay? What shape do I have? Parabola, which means what kind of function do I have? Quadratic. And then we learned how to write quadratic in what form? Y equals a bracket remember, you don't have to memorize these. They're everywhere in your classroom, right? You can always refer back to them, right? They're here. They're on a green sheet of paper, okay? This is called what form again? Vertex form. And we call it the vertex form because it's easy to find the vertex, H and K, right? So, do you remember we did a lesson on how to write an equation, right? Given points. Do I know points on the graph? Yes. What are the points? So I have -3, -4 here. 3 and -4. And there is a very important point that I need to know in the vertex form, which is the vertex. And what's my vertex here? 0, 0. So my vertex is 0, 0, and that's very important because that's the first thing I'm going to plug in. Okay? Vertex represents what letter again? H, K. Okay? You remember this? First thing you're going to do, you're going to plug in your vertex in your equation. So I'm going to plug in 0, 0 for H and K. What else do I need to solve for?
A.
A. And how do I solve for A? Plug in one of the other points, right? Vertex is very important because I have to plug it in, but I need to plug in one of the other points in for X and Y.
Does it matter which one?
It does not.
Matter.
It does not matter.
Just
Okay?
either of them.
Either of them would work. I personally would pick the one that has less negative numbers just because it's easier. Okay? Doesn't matter. Both would work. Exactly the same. So I'm going to pick the 3 and -4. Remember that X, Y. Your point is alphabetical order. X, Y. So Y is going to be replaced by -4 equals A. Instead of X, I'm going to replace it with 3 minus 0 squared plus 0. Okay, what do I do next?
Bracket.
Do the brackets. Simplify. So -4 equals A. 3 minus 0 is 3. Squared is 9, yeah. So it'll be -4 equals 9A. What's 9A plus 0, guys? Do I need to keep that plus 0 there? No, it's useless. I'm adding nothing, right? So technically, that's 3 squared, which is 9, 9A. Even if I write the plus 0, it's not going to affect anything, right? So I can, in this case, I can just ignore that. Then, divide both sides by 9, right? Because I want to isolate for A, okay? So I'm just going to bring it over here because I have more space. -4 over 9 equals A, and that is my A value. Does it make sense that my A value is negative? Yes, because it's opening down, right? So once you solve your equation, make sure that you actually look at your answer and see if it makes sense. So I'm going to rewrite it. Y equals, instead of A, I'm going to replace with -10 over 9, sorry. What's X minus 0? X, right? Do I have to write X minus 0?
No.
Can I write it just as X squared?
Yes.
Plus 0, do I need to write that?
No.
No. So I can leave it like that.
Wouldn't you have to divide? Like actually divide -4 times 9?
You have to do negative 4 divided by 9. You don't have to, you can leave
But
it.
would it be wrong if you didn't? Because
It wouldn't be wrong, but if your answer is like 0.3579, blah, 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 right? It won't be as accurate as if you leave it as a fraction. Okay? Accuracy purposes, we leave it as a
Because I always forget to like leave things as fractions, like I actually divide everything.
Again, like it won't, if your answer is like straight 0.68, why not? You can write it as a decimal, but if your answer is like,
It's just like a really bad habit, and
we'll try to get rid of it. Okay, now, if I look at this, does my equation make sense to you, right? First of all, I'm looking at it, okay, A is negative makes sense because A is opening downward. I'm checking my work, okay? I'm checking my knowledge. Oh, okay, I don't have H, I don't have K. That means H and K are 0, 0. Does that make sense? Is that what I have for H and K? Yes, right? So think about it when you write your final answer. Think about your answer. Are we good with that? Mm-hmm. What do you mean by find x and y? You can't put it in. It has to be y and x. Your equation has to have y and x. Are you talking about your final equation or about your... Are you talking about your final equation? What do you mean by when you're working? It won't help. You need to put the H and K first. Okay. All right. Here's another problem. A football was kicked. Its path can be modeled by the relation H equal to negative 0.1 D minus 8.7 squared plus 7.6, where H is the football height, H is the football's height above the ground, and D is the horizontal distance from where the football was kicked, both in meters. Okay? So in this case, I don't see X and Y, I see H and D, but does that change anything? No, right? They still have the same meaning, right? So H is your Y, right? It just, instead of calling it Y on this, I'm gonna call it as the height of the ball, right? So that's the only thing. And then D is replacing the X, and that's the distance from the kicker, right? It's how far away from the kicker, okay? So it's still the same thing, it's just I'm calling them different letters. Are we okay with that? Now, what is the vertex of the parabola? First of all, I know it's a parabola because degree 2. Degree 2. All right. What's the vertex? 8.7 and 7.6. What's the football's initial height?
0.
So you would think it is on the ground, right? And you would think that you're kicking it off the ground, right? It could be, but we are not sure. Maybe it could be on a little platform, or it could be in the air that we're kicking it. So we can't assume that it is on the ground, okay? Huh? Okay, it's on the picture, but that doesn't mean that I always put the right picture for the right question. You can't assume.
You made
Okay.
these questions?
I didn't make them, like they're in textbooks, but I put pictures. Now, question for you guys. How would I know what is the initial height?
Wouldn't it technically be the x? Like x is 7.6
Okay. I know what you're thinking about, but it's not in that format. Okay? We'll talk about that in the next unit. But think about this. It can't be this because that's your highest point, right? This here is your vertex. So it can't be your initial height. Okay? I know what you're talking about.
Your x-intercept? No.
So I'm going to just sketch it. Okay? I like to sketch things. So a ball has been kicked, right? It doesn't have to be that it's kicked from the ground, and then it could have been like right above the ground, it went up, and then it landed, right? That's what we're expecting, right? Yes? So kick the ball is gonna go up, it's gonna reach a maximum height, and it's gonna land on the ground. Okay? Now, eyes on me for a second. What is the football's initial height? What point am I looking at? Name it for me, because you know the names.
Optimal value.
No.
The
The y-intercept. I'm looking for the y-intercept. Right? Because that's the initial. Now, what's the value of the x for the y-intercept?
8.7. What? Sorry, can you ask that again?
I will. What's, for any y-intercept, forget about this question, for any y-intercept, what's the value of x? 0. Remember that we wrote for y-intercept, we wrote this, 0 and a value. You remember that when we were doing the points? Maybe not. But, how far away, think about it this way. I'm going to kick the football. How far away is the football from me right now before I kick it? How far away from me?
It's right in front of you.
It's right in front of me. It's right at my leg. So there's 0 distance between me and the ball. Right? So that means my x value or the x value, the initial x value is 0. Right? So that means the initial distance is 0. Yeah? Anytime it asks you for initial value, you're looking for x equals 0. Or in this case, instead of x, I have d. Right? So, what is the football's initial height? I have to plug in 0 for d.
Oh, so you would just like rewrite it?
I have to evaluate. Okay? So d is equal to 0. So if I plug in d is equal to 0 to find the height, that's a negative 0.1. If you're going to do this on the calculator, you can enter it. If you have a good calculator, you can enter it all together. Or if you don't have a good calculator, what do you have to do? What do you have to do first? Backmass, right? You have to do your brackets, exponent, multiplication, addition. I want you all to try this with me on the calculator. And tell me what you guys got.
Fraction form, right?
No, decimal.
0.031.
Did we get that? The height is 0.031. So was the football on the ground? Close to the ground, but not on the ground. Right? It was like maybe on a little platform or on a little like T-ball or whatever it is that they put the football on. You know? That little, what is it called? Where do they put the football before they kick it?
That little like.
Into the ground and they push it into.
Yeah, but then it's not on, like it's not literally in the ground. It's like 0.031 meter above the ground. Apparently, I don't know. Don't ask me. It's a question. Okay. So the initial word problems. What do I have to end it with? A therefore statement. A sentence. The initial height of the bulb is 0.031. Make sure you include units. So what we've learned so far, if I want to look for initial, I plug in 0 for x. So I know 2 points so far.
Wait, so if you're trying to find like D in this situation, would you put 0 for a y?
That would be your x-intercept, right?
Yeah.
Yeah. But then we're not going to do that here.
No, I'm saying like,
Yeah.
if it was like.
Yeah. Now, they want me to graph, right? I know 2 points so far. I know the initial point, and I know the vertex, right? Okay. It's going to be very hard to use step pattern here because negative 0.1, right? That's very, very hard to graph. Technically, we're going to sketch, not graph, okay? Sketch and graph, they're two different words. Sketch is approximately, show me how the graph is going to look like. Graph, that means I want to see clear points, okay? So I'll show you what's the difference. Oh, let me try this again. There you go. So I have the H, I have D, and they're both in meters. Okay. If I can do, okay, that's 1, 2, 3, 4. I feel like it's not going to fit properly, so I'm going to squeeze it a little bit. One, 2, 3, 4, 5, 6, 7, 8, 9.
I can't see like the points on the paper.
Just, it's an approximate. Remember, it's not. Now, keep in mind, points are not very. Okay, now, I know the first point, which is 0 and 0.031, right? Which is going to be like literally very, very close to the 0, 0, but not at the 0, 0 yet. Okay? Close to it, but not at the 0, 0. Now, my second point was, or my vertex, what was my vertex? 8.7, 7.6. So 8.7 is about here, and 7.6 is about here. Okay? So what I'm saying is this is a sketch, not a graph. Okay? So I know that my 8.7 and 7.6 are not going to be 100%, right? They're about that place, in that spot. Now, and 7.6. So 8.7 is between 8 and 9, and 7.6 is between 7 and 8. Now, is it enough to graph with 2 points only?
Yeah.
That's enough?
No.
So if it's a line, it will be enough. If I'm graphing just a line, that would be enough. But it's not a line. It's going to go up, but then it's going to have to go back down because it's a quadratic, right? So what do I know about quadratic graph? That?
Whatever you do on one side happens to the other side.
Exactly. because of the line of symmetry, right? And my line of symmetry is gonna be through my vertex, right? So this is where my symmetrical line is, right? So from here on this side of the graph, it's gonna have to equal to the other side of the graph. Okay? Now, where would I place my other point?
Wait, what point is that?
Which point?
The top one?
That's my vertex.
Just before 16.
Sorry, what did you say?
You said just before 16.
Just before 16 or just after 16 or after 17?
Because there isn't very much more you can go on.
Yeah, but look at this. From here to here, I have 8.7, no?
Yeah, and it's just
Right?
past that.
So that means from here to my next point, it's going to have to be 8.7, right? 8.7 and 8.7, that's 17.4, right? So it's going to be about here. Okay? And then I can sketch my other point. Okay? So I'm using my symmetry shape to find my other point.
Isn't that, what's that, isn't there a name for that though?
Symmetry shape.
No, like for the.
Axis of symmetry.
Yeah.
That's the line of axis of symmetry, yeah.
So
And then
you
because
use that to like,
to predict where the other point is going to be.
and that's the x value on the vertex.
The axis of symmetry, it is the x value of the vertex. Yeah. Okay. So do you understand that? This one is 0 and 0.031. This is my initial point.
Wait, how did you get 17?
So because this is 8.7, right? And I'm gonna have to go 8.7, another 8.7, yeah.
Okay.
Okay. That's how I know where my next value is going. Okay. Yeah. It's going to be very hard to do step pattern here because it's 0.1. Okay? So if it was something other than 0.1, it was like 0.5 or 0.10 or 0.5, or let's say it was 2 or 4, then yes, it will be easier to use from my graph to use the step pattern from my vertex, right? But because it's negative 0.1, it's going to be very tough to find the other points, right? Because can you actually draw 8.6? Right? Sorry, not 8.6, 7.5. Right? You're going to have to go, the next point is going to be at 7.5. And the next point is going to be at 7.3. Right? So it's very, very tough to find the next point. So that's why we use the symmetry. Okay? What does the vertex represent in terms of the football path? What's the maximum height of the ball? What's the, yeah, but what is it? So the maximum height of the ball reaches 7.6 meter. Yeah, so that's what it is. That's the maximum. The optimal value is the maximum height, right? So you're going to explain this as the ball reaches the maximum height of 7.6 meter. How far away from the kicker? 8.7 meter away from the kicker. Right? So if I kicked it here, the ball is going to reach a maximum height of 7.6 meter, which is way too high. Okay? 8.7 meter away from me.
That guy can't kick.
Can't kick? I don't know. Can kick better than me. Don't laugh at me, guys. But when I watch basketball, right? That's all what I see. Parabolas.
Oh my
So
god.
math has ruined sports.
I would hate.
Oh my no!
That's actually
It's fun.
some basketball trainers say. Just imagine a parabola or imagine
Yeah.
a
Here you go. Here you go. That's what I see. And if the parabola is perfect, then I know it's gonna go in. Okay.
That's actually really funny.
People hate me when I say this, but don't hate me.
basketball.
It's like quirky.